Assalamu alaikum and welcome everyone, chapter 4.5 of the Arduino series. In this video we're going to be covering the 28BYJ-48 stepper motor with its dedicated driver. To start off with the components, you're going to need 6 female to male jumper wires, the Arduino, the stepper motor along with its dedicated driver, and if you wish to follow along you're going to need the breadboard, a resistor, I'm using 330 ohms, a switch, and 3 male-to-male jumper wires. The way the motor works is quite simple. It rotates in increments of steps. Now, if you want to calculate the angle per step, you're going to need to take 360 divided by the total number of steps. If we go about using the most common number of steps in each motor, which is 200, and use it to divide 360, we're going to get that each step makes a revolution of 1.8 degrees. Regarding the circuit, I begin by making a pull-down resistor on the breadboard, which means when I press the button, it will input a 1. In my case, I supply the switch with 3.5 volts and I ground it normally. Even though the driver can take in more than 5 volts, the motor can only accept 5 volts and we have to respect this or we're going to end up frying something in our circuit. I begin by connecting the 5 volts from my Arduino onto the plus pin on the driver, and the minus pin I end up grounding it onto the Arduino. Take the order of the jumper wires that you have on the driver and mirror it exactly onto the Arduino. In my case, I have 8, 9, 10, 11 used, and pin 5 will be in charge of recognizing the state of the button. For the code, I'll begin with the variables. Pin 5, which is going to be the bottom pin, is dedicated to checking the status of the switch, and the next 4 pins are the ones associated with the driver. I also have a variable that's in charge of checking the next function, which I'll explain, called step num, and the next one is a boolean to check whether the button is active or not. In the void setup, I told the Arduino that the pin that's connected to the switch will be an input, and the 4 other pins that are linked to the driver will be an output. I also activate the serial monitor by using the command serial.begin with a baud rate of 9600. In the void loop, I define the boolean variable button active through the command digital read button pin, followed by an if statement with the condition that if the button active variable is equal to 1, which means it's true, then perform my custom function called step and make a delay of 2 milliseconds, which is 0.002 seconds. And I chose this value because this is the minimum delay between steps, and to print the status of the button. There's another if statement with the condition that if the button active has the status of false or 0, then to print not rotating. Now moving on to the custom function I named step, I use the switch function, and within the brackets I have step num, which is the input that I'm going to apply to this switch function. And with it I have different cases, and if you notice there's a trend where that as you go down there's a movement of the high pin, and in each case a different magnet will be activated in the stepper motor which will cause the rotation. After the switch command, I increase the value of the step num by 1, which will cause it to activate a different case, and if the case reaches more than 3, then to make step num equal to 0. And if you haven't noticed, step num is in charge of activating different case. So if step num is equal to 1, it's going to activate the first case. If it's equal to 2, it's going to activate the third case. Now do keep in mind this stepper motor is quite cheap, and due to this it does sometimes skip steps, so it does decrease its accuracy and precision. But you can always just purchase a more expensive one, or you can purchase servos which are more precise and accurate. If you wish to join the community that I'm trying to build, there's going to be my Discord linked in the description, and if this video has helped you out in any way, consider giving it a like.